Hello everyone. Today I will be talking about mechanical properties of solids. This topic helps us understand how solid materials respond to external forces, something crucial in engineering design and everyday life. Let's get started. When we apply a force to a solid, it can change shape, stretch, compress, or even break. The way a solid reacts depends on its mechanical properties. These properties determine how strong, flexible, or rigid a material is, and they play a vital role in designing buildings, machines, and tools. Interatomic forces in solids. In a solid, atoms are arranged in an orderly pattern and are held together by interatomic forces. When we apply a force, this atom enter, come closer, or move slightly apart. The strength of these internal forces gives the material its rigidity and its ability to resist deformation. Next, we come to elasticity. One of the most important properties of a solid is elasticity, its ability to return to its original shape then after the force is removed. When this happens, the material is said to behave elastically. But if the shape change is permanent, it's plastic behavior. According to Hooke's law, within the elastic limit, the deformation is directly proportional to the applied force. This is written as stress equal to Young's module into strain stress, that is equals to Young's modulus multiplied by strain. Next, we talk about stress and strain. Stress is the force applied for a unit area, where sigma equal to Fa divided by sigma. Its unit is Pascal. Strain is the change in the shape or size compared to the original. It has no unit. Since its ratio together this define how much a material deforms under force. Next we learn about types of strains and stress. There are different types of stress and strain depending on how the force is applied. Tensile or compressive, whether the force is along the length. Shear, where force is applied tangentially, and bulk, which comes from uniform pressure causing volume changes. Elastic moduli. We use the three types of elastic moduli to quantify how materials respond to different types of stress. Young's modulus measures resistance to stretching or comparison. Shear's modulus measures resistance to change shapes. Bulk modulus measures resistance to change volumes. All are defined as the ratio of stress to the corresponding strain. Next, we talk about stress-strain curve. The stress-strain curve shows how a material behaves when stretched. Initially, it follows a straight line. This is the elastic region where Hooke's law holds. The elastic limit is the maximum stress it can take and still return to its original shape. Beyond this is the plastic region where deformation becomes permanent. Eventually, the material breaks at the fracture point. Factors affecting elasticity. Elasticity is affected by several factors such as the material's internal structure, metals, rubbers, and ceramics all behave differently. Temperature. Higher temperature generally reduce elasticity. Impurities or defects in the material. Shape and size of the object. Next, we talk about the applications of elasticity. Understanding elasticity is essential in real life. Engineers use it when designing bridges and buildings. Spring shocks observer and rubber bands rely on elastic properties. In medicine, artificial joints and implants must have the right mechanical properties. Aircrafts and vehicles are built using materials that balance elasticity and strength. Thank you.